So have you ever seen those movies where they're in college and then the professor's like got this ridiculously long equation up on the board and it goes like all the way down, 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 down. And then it's like, it could end up, if you were taking notes on it, it could end up being like 3 pages long. Okay. This won't be that impressive, but this will be the longest solution, the longest equation you have ever solved. It'll probably be like 9 steps. Do, 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 do. And at the end, you get your answer. Okay? So you won't go all the way down a whole blackboard, you know. The college professors have these blackboards that are kind of cool where they can slide it up and then it reveals another blackboard so that the blackboard that's got all the writing on it can stay there. You know what I mean? Except up higher. And then they slide it up and it reveals another blackboard that then they can write the rest of the problem on. Thought that was a pretty good solution back when there wasn't such a thing as digital. Nowadays, it'd be kind of cool if we had a projector that was double tall so that you could scroll up and you could still see up above. What I can do, that a lot of people can't, is I got 2 smart boards, so I can take the beginning of the problem, snip it, drag it over there, but I found it's not as useful as I thought it was going to be. I thought it would be, but it's just harder to get stuff over there. So what I really wish is that the other screen was above this one and I could just keep going and you could see what I wrote on the last slide above this slide. You know what I mean? Because a lot of times kids want to see the slide before this one. Anyway. Okay, so when you're solving, you're trying to get x alone, right? So normal solving, we'd start by adding 18 and then we would divide by 5. Does that ring a bell? Just normal solving? All right, so how about this one? When we solve a quadratic, there's a little statement I want to remind you about. If you can factor it, you should. Go ahead, factor this one, and we'll solve it by factoring. By now, I hope factoring's in your wheelhouse where it's like, oh yeah, x and then 2 numbers, and it shouldn't take you too long. We've been working on this since the beginning of the year, and now we're 2 months in. If you're still not good at factoring, frankly, you have a factoring problem. And if so, you should come in and get some help for that problem. I can teach you this one-on-one if necessary. All right. Let's say I think I've got it, but I'm not sure. Do you get this as one of the problems in math that you can just be sure you're right? You just multiply it back out, and if it multiplies back out to the same thing, then you're good. So the first make x squared. I like to do it this way with outside and inside next, and that makes 3x and negative 6x, which makes negative 3x. Wait a minute, that's the opposite of what I wanted. So what do? Change the signs. If it's the opposite of what you want, you change these to the opposite signs. There. Now does it work? Now all the first 7 changed, so we're good there. The outside and the inside are now 6x and negative 3x. That adds up to positive 3x. Now I know it's right. Get how that's important to check? Because you don't want to just assume you got it. A lot of people do that. They think, okay, I think I got it. And then they keep going. Make sure you've got it. And then x plus 6 has to equal 0, and x minus 3 has to equal 0. I know you're used to just doing those in your head, but I'm just showing you what you actually are doing is solving 2 little equations. 3 and negative 6. What are those? Those are the answer. They are what x is. Do you get I can stick them back in the original and they'll actually work? Again, if my life depended on it, I would check this by seeing if 3 actually works. Does it? Yeah, because it makes 9 plus 9 minus 18 equals 0, and that's all true. Okay, I'm not going to check it, but negative 6 would also work. Okay, so now, what happens, though, if it wouldn't have factored? Do you get it still could have been solved if this had been a 17 where it didn't actually factor? That's what we're teaching you to do today. Is what happens if you can't factor it? If you can factor, you should. If you can't factor, you can always do what we just did yesterday, which was called completing the square. You might be thinking, well, what do you mean? How would I use complete the square, that finds me the vertex. That doesn't give me the answer. You're right. That's what it normally does. I'm changing the problem. Notice, again, 17 and 18 are not the same thing. I'm changing the problem here. Okay? Now it won't factor. But we can use complete the square, and I'll show you how that would work. Do you remember the complete the square thing where you do a space in between here? And I made an extra space so I could put in plus something and minus something. Why don't you go ahead and do the complete the square thing. And when you're done, just make sure it says equals 0 at the end. Now pause for a second while you finish the complete the square. Okay, you should have said, ooh, half of 3, icky. What is that? Half of 3 is 3 over 2. Good, that's half, and then we gotta do what to it? Square it. And then we gotta go minus half and squared. And then I can put this all together. At least this part cleans up nice. X plus 3 over 2 squared. And then this part is a little icky. It makes 9/4 minus 17. Oh, ick. So then I got to go 17 times 4 and get a common denominator. I didn't mean for it to be that complicated. If you got that far, raise your hand if you got that far. Okay, good. We're going to stop right there and cut our losses because these, as I told you before, can take a whole page. And if you throw a fraction in on the very first one, it's good that you got this far. Good enough. Let's do this one because this one actually works out clean and nice. So start by, since you can't factor this, if you tried for a while, you'd figure out that, no, I can't factor it. Go to the quadratic, no, not quadratic. Go to the complete the square thing that we just learned and complete the square on this one. And there's normally no fractions involved this time. Because when we do these, if you add a fraction into it, I think it's too hard even to put on a test. So, unless it was like a, I don't know, really simple except for one little fraction or something. Okay. I'm going to leave a little room. Half and square, half eight's 4. 4 squared is 16. Even if they're big numbers, at least they're not fractions. Now this part factors. X plus 4, quantity squared. Those two together make what? Negative 34. There we go. How many of you got that far? Cool. Now, this is the part that's going to maybe blow your mind a little bit. You can just solve it. What? What do you mean? Just solve it. Well, solve it. We had tests. This kind of question was on a previous test. You just had never thought about before how you could actually just do the, like, subtract this and then add that and then square root this and then, yeah, you just have to solve it. Again, you got tested on this. I know you can do it. How do you start? Add 34. And then right there, some people will be stumped because I know it looks kind of complicated, but you're trying to get the x alone. Square root it. And if we can get you to get this far, the next common mistake is to think, okay, squared and square root cancel out, so I got x plus 4 equals square root of 34. Wrong. It's close. Who remembers what to do? Absolute value. Because the square root of a variable is the absolute value of it. I showed you that by making you graph this, and it came out to this, and it was an absolute value graph. Remember that? So it's the absolute value of x plus 4. And that, Carson, remember what to do? Nope, not yet. FK, read me those two equations. You got it. Does that ring a bell? Do you guys remember that? And then we're going to do what you said, which is subtract 4. But if you do it too early, goose things up. I have had to hit extend the page like 4 times now. There. That's it. We got to the end. See how intense that is? You start with complete the square. Once you're done with the complete the square process, then you start subtracting and dividing and square rooting things, and then you get an absolute value, and then the absolute value has to be broken up into 2 parts, and then you get two different answers. How could you have known you were going to have 2 answers from the very beginning? Because it has a squared in it. If it has a squared in it, there'll be 2 answers. When you move to honors pre-calc, we get a lot more x to the thirds, x to the fourths, then they have 4 answers. X to the fifth, they have 5 answers. Our biggest thing we do in honors pre-calc, the kids have to come up with 6 answers to a particular equation. All right, so one thing at a time. Let's make sure, how many kids got this one right? I'm curious. Oh, it's almost everybody. Now, I did kind of walk you through it, so let's see if you can handle this one without any help from me. And if you can factor it, you should, and you should see if you could just solve it by factoring, but I'm going to save you some time. This one won't solve by factoring, so you may as well just do the complete the square deal. This one's just a little ickier than normal because it's got this 3 in front. Can you handle it? Yeah, factor the 3 out. Yes?
Okay, so I have a question.
Mm-hmm.
Do you know how you do the half and square?
Yes? You don't start with half and square, though.
No, but like after you factor it
Yes.
out.
So just a second. Let me get that far, and then I'll help you from there. So then I'm factoring the 3 out, and then I got this, and this minus 6 is way over there still. Remember, that's all separate. Okay, do you agree so far?
Yeah.
Now ask.
So when after you factor the 3 out, though, it should be 2x, right? Instead of 6x.
Oh, you got me. Thank you.
So do you have to square the 6x, or do you have to square the 2x?
A 2x. That's why I make such a big deal about not starting with half and square, because if you did, this number becomes way too big and it screws everything up. So you want to factor it down first, and then we take half of the 2x, which is 1, and then we go half and square it, so that'll be negative 1 times negative 1 is positive 1 plus 1 and a minus 1, and then one last thing, it still equals 0, right? And one other little thing, I've made a mistake, I know it. I just did it on purpose. What did I forget? It's the number one thing people forget on these questions. Remember me telling you? Where's that one spot? Sir? Yes. This 3's going to make that scale up to be 3 times bigger, and this won't cancel that anymore. So this one has to also be times by 3. Do you remember that? Okay. So now here's my new equation. 3x squared minus 2x plus 1. And then 3 times negative 1 makes negative 3. Minus 6 makes negative 9 equals 0. And then as this scrunches down, that can become x minus 1 squared. There. I now know the vertex. But I didn't even want the vertex. I wanted you to solve. Can you do the 6 remaining steps to get the final answer? That's the question. Now, this is algebra 2. This is higher level algebra. So it should involve some complicated equation solving. Here it is. I'll pause for a second while you try that. Then we'll take it from there. I'm adding 9 to both sides. And just to save myself having to rewrite all of this, that just cancels, and that's just 9 then, right? Now I'm going to divide both sides by 3. And just to save myself some time, that's going to cancel, and 9 divided by 3 is 3. Now this next step I'm not going to try to do without rewriting. I'm going to square root both sides, and this becomes absolute value of x minus 1 equals square root of 3. And then, at that moment, I don't add 1. Please don't do that. Instead, tell me what to do. KL. Break me up into 2 equations. You got it. And then I'm adding 1 to both sides. She's right. You have a question? Why did I square root it? Because both sides had to be square rooted. See this blue lines right here? This is me square rooting the left side. This is me square rooting the right side. The right side was a 3. It was a 9 until we divided by 3. We divided by 3 on both sides, and it became a 3. All right. So, I know, that's intense. So many places where you could screw up. I found every time we have another, like if it's got 6 steps, definitely decreases how many kids get right because they have 6 chances to mess up. When questions were only 2-steppers, like they were in algebra, regular algebra, it's not that hard to do 2 things right in a row, right? But it's hard to do 6 things right in a row or 9 things right in a row. So these will be marked wrong a lot on this next test because some kids, all it takes is skip 1 thing. Oops, I forgot to divide by 3 there. Or, oops, I forgot a negative here. All right. Now, I want you to just stop for a moment and think. That answer right there, that answer is like 1 plus square root of 3. Square root of 3 is like 1.6 or something like that. So that means the answer is like 2.6-ish. What does it do? If I put 2.6 here and here, it solves my equation. Do you get that I got that answer without having to ever use a calculator? That's pretty cool. Granted, I have an answer of a square root of something. You know what I mean? I never actually got the decimal. But square roots, they're rational. They're real numbers. So anyway, you solved something really complicated, has really weird decimal answers, and you did it all in your head without a calculator. All right. So now, how could they get more complicated? Just because sometimes people forget how to factor out a negative, for example. And this one has a y here, and you're supposed to know what to do. Aren't we trying to find the x-intercepts? So let's finish this sentence for me. The x-intercepts are where you set y equals 0. So that means this, you have to know how to, oh, I guess I better make it a 0 to get the x-intercepts, also known as the solutions, the roots. And I also got to know how to factor out that -1 first. Just these 2 terms have to have a -1 factored out of them. See if you can handle that one. And this is the last one we're going to do as a group. And after that, I want to just show you your homework. Get the homework started with you. Answer. Okay, this one you should have started by saying 0 equals -1 gets factored out of the first 2 things, x squared minus 10x, and then minus 12 is still over here. Then I do half and square. Notice I waited till after I factored first. Now I'm going to do half and square. Half of 10 is 5. 5 squared, 25. Minus 25. But wait, this -1 has to hit that -25. I probably, as a couple of you, forgot that. Okay, then. Let me think. Minus 5. Nope. X minus 5 squared. And then that's positive 25 minus 12, which makes positive 13. And then, what do I do now? I start solving it. What's the first step? Subtract 13. How do I get rid of a -1? You can either multiply by -1 or or divide by -1, whichever you want. Pick one. Divide by -1 then. And this cancels. And what's -13 divided by -1? +13. I'm just saving myself a step by not having to rewrite everything there. Now I'm going to go square root on both sides. Now I need absolute value here, and I'm going to bring it over here. Absolute value of x minus 5 is equal to the square root of 13. I just made things switch sides. It doesn't hurt anything. If you want to do it backwards, it's fine. But I kind of am used to having my absolute values on the left side. Now I'm going to split it. X minus 5 equals square root of 13. And x minus 5 is equal to the negative of square root of 13. And I add 5 to both sides. Plus 5. Plus 5. X equals negative root 13 plus 5 and root 13 plus 5. Raise your hand if you had that one right. Awesome. Okay, that's it for today. Now, let's look at the first problem of the Schoology quiz, because it's weird in how you have to enter the info. Okay, like the answers are kind of like this, except how do you type in square root 13? And how do you do, which one do you put first? Okay, so let's do the first one of the homework quiz together. There's only 8 questions, and we'll do that first one. Here we are in the first problem. You would start by hitting square root, and then you'll get absolute value. And where are you supposed to do all of that? If it were me, I'd have a Schoology doc open where I could be like doing this, not Schoology, sorry, Notability, where I could be doing this off on the side. But if you want to use paper, like regular, like made out of trees, paper, it'd be fine. And then I got to split it into 2 things. X minus 2 equals square root of 12. X minus 2 equals negative square root of 12. And then I'm going to add 2 to both sides. X equals square root of 12 plus 2. And this one's x equals negative square root of 12 plus 2. Then, this is important and why I'm doing it with you here. Enter the smaller solution first. If your answer involves a square root, then do it like this. Does our answer involve a square root? Yes. If there are 2 answers, we're supposed to put the smaller one first. How do you know what's smaller, this or this? Hint, this is 2 positive numbers. That's going to, when you add them, make a fairly bigger answer. This one's got 1 negative one and 1 positive one. That makes this the smaller one. Next, it already says x equals blank and x equals blank. That means you don't type in x equals. Get what I'm saying? It already has x equals on it. So how am I going to type this in exactly? I'm going to say negative SQRT. I'm giving you an answer that you can type in directly. Negative SQRT parentheses 12. That's how you say negative square root of 12 plus 2. That's your first answer. Okay, and who remembers my favorite saying? Because for problem 2, right here, you're going to use it. Can factor? You should. This one will factor. You don't have to do this big, huge, nasty, terrible process. You just factor this thing, and you'll get the answers, boom, boom. You know what I'm saying? So if you can factor, you should. Because if it won't factor, then we got to do this long process I just taught you. But don't forget, can factor it, you should, does apply. Now, some kids that didn't hear that are going to do it the long way, and they'll get the answer. It's just they'll do it like in 12 steps instead of factoring it. You get the answer like right away. So in other words, it'll still work if you don't notice that it'll factor, and you just go through that whole process of completing the square and solving. It'll work. It's just a bajillion more steps. Good question. It does say enter as coordinate pairs. That's another way to say ordered pairs, so yes. And it does say the smaller x value first. And remember, I'm not too tough if you just make entering errors, but I know you'd rather have a high score right off the bat. Okay, now let's look at question 3. That's the first one where you're going to have to, because you can't factor that puppy. You might think so, but you can't. If it won't factor, then you can use complete the square. And then I go half in the square, half of 10's 5, 5 squared 25, minus 25. And that's all equal to 0. So once you get that all cleaned up, this part's 7, negative 7, sorry, it's negative 7. So you're going to add 7 to both sides and then take a square root, and et cetera, et cetera. Okay. Now, last night's homework quiz, I did find one mistake on it. It was problem 1. If you were confused by problem 1's answer, I thought it should be 9, and I double-checked it, and it should be 9. It shouldn't be 27. It was 3 times as big as what it should have been, so I get what the teacher was thinking when they typed it, but anyway, I changed it. So if that confused you last night, I apologize. If you ever think there's one that's wrong, you're like, I really think something's wrong, and just tell me, because you'll help a lot of kids. You know what I mean? Because as soon as I find out that, I tell other teachers too. And there's 300 kids that are doing the same problem you are. And if you realize there's a mistake in it, let me know, and I'll save. I don't know. Not everybody's going to even notice, but probably 30 kids will be happy that you told me. So if you think there's a mistake in here or a mistake in a key, let me know. Okay, and that's all I got for you for today.